we have looked at a lot of terminology related to sequences and series. We know what a term is represented as u sub n. It represents a single number. Sequence u sub n is nothing but an ordered list of numbers. Series is the sum of all the terms. And remember, there are infinitely many numbers in the ordered list. So when we add up all these, we call it as a series. Now, here n equal to 1 to infinity may or may not be specified. If it is not specified, it is understood that it is n equal to 1 to infinity. So basically, it doesn't have a, it is not a number, but an instruction. Now, how to figure out that value of that is up to us. Now, partial sums S sub n is equal to the sum of first n terms. Sequence of partial sums, as mentioned, for sequences, it's a list of ordered numbers. Now, what those numbers are the partial sums. So here S1 will be U1, S2 will be U1 plus U2, S3 will be U1 plus U2 plus U3, and so on. And this is the central object of series theory. A limit of general term as n goes to infinity of u sub n gives the necessary condition, that is, it should be equal to 0. But remember, it does not imply convergence. Limit of partial sum, limit as n goes to infinity of s sub n. If we get a finite value, it means the series converges. And if limit is infinite or there is no limit, then we say the series diverges. Now, yes, in a lot of sessions that we have already covered, we have looked at various methods by which we can figure out whether a series converges or diverges. We have looked at various examples. But at some level, I'm sure that it's a little bit confusing. So let's define a process for finding out the convergence divergence. First step is to write the general term, u sub n. Now, it might happen that it is given, then this step is not that important. But many times what happens that the series is given in the expanded form. In that case, we have to figure out the nth term. Now, if limit n going to infinity of u sub n is not equal to 0, the series diverges. So immediately you stop the process because you have reached a conclusion. But if limit of u sub n is equal to 0, the necessary condition is satisfied for convergence, but does not imply convergence. That means it is a necessary condition, but not a sufficient condition. The next step is to write S sub n, that is the nth partial sum of the series. And now we find the limit as n goes to infinity of this partial sum, nth partial sum. If it exists, the series converges. If not, the series diverges. If we have reached a conclusion here itself, then we don't have to proceed any further. But many times what will happen is that this limit of nth partial sum as n goes to infinity cannot be evaluated explicitly. Then we use comparison tests to figure out convergence. Remember the convergence tests? Comparison test 1, that is direct comparison of terms, term by term. Comparison test 2, test 1 and test 2, remember, we have a auxiliary series. So here we are comparing the given series with another series. And then we have the comparison test 3, the ratio test. Here, the ratio of successive terms are being used. So, the process goes like this. Write the general term, take the limit of that general term to infinity and see whether we get 0 or not. If we don't get a 0, that means the series diverges. Stop. If it is equal to 0, that means the necessary condition for convergence is satisfied. So that means we have to proceed, because remember, it doesn't actually tell us that it is actually converging. Now we have two paths. Either we go towards partial sums or we go towards comparison tests. Third one is also a comparison test. Remember, the ratio test. Even though we are comparing the ratio of successive terms, in the background, there is a geometric series lurking around. Okay, so if we are able to figure out the nth partial sum of the series, then we proceed with this. Or if this is not easy to figure out, then we proceed with comparison tests. So that is the process for finding convergence. In the next few sessions, we will be looking at a lot of examples using this process. So be clear about this steps involved. This is going to be a brief session. So if you liked it, please do like, share, and subscribe. Comment suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.